Hello everyone. Today we're looking at the problem longest common prefix of case strings after removal, which was question 3 in Biweekly contest 152. So the question reads that we're given an array of strings, words, and an integer k. So for each index I in words, we want to find the length of the longest common prefix among any case strings after we remove that word at the ith element. So we want to return an answer where answer I is the answer for the ith element, and if removing the ith element leaves fewer than case strings, the answer is 0. So really what this is saying is that we want to go through each word, and basically we're going to remove that word from consideration for that index. And we're going to say, once I remove this, what is the longest common prefix of any of the other k strings in there? So really what we're trying to find is the longest common prefix for each element in this problem. So looking at the example, jump, run, run, jump, run, where k equals 2, our output would be 3, 4, 4, 3, 4. So first example, we're going to remove jump from the array. So words becomes run, run, jump, run. So run occurs 3 times. So our longest common prefix is run, which is 3. You might be asking, why don't we just use jump, right? Because this is 4 characters. Remember, it has to occur at least 2 times according to our k. So we cannot use jump, and we can instead use run. So the second example, we're going to remove run. Here, our longest common prefix is 4 with the word jump. And here we can use jump because jump occurs twice here. So really the rest of these cases are the same, removing run, jump, run, but you can see that we have to make sure that after we remove, whatever our longest common prefix is still occurs k times. So whenever you hear prefixes in a problem, you should always think of a trie. A trie is a great data structure for dealing with prefixes like this, and it's what we're going to use for this problem. But there are a couple extra little things that we have to do with our trie. So I won't go too deeply into exactly how a trie works here, but basically it allows us to map all these prefixes out in a tree-like structure. So I'm going to start with the root of our trie, and what I want to do is I want to add all these strings into this trie. So I'm going to start with jump. So now I have added jump into my trie. So you can see that from my root, I have one connection for j, then from j, one for u, from u, one for m, and from m, one from p. But I'm also keeping track of a number, and this number is the number of times that I actually see this letter, right? So that means the next time that I add jump, what I'm going to do is I'm going to come down the same path, but I can increase this value by 1. And you'll see exactly why we use that. So now let's go over to run, and I'll do the same thing there, adding run into my trie. So now I've added run into my trie as well. Very similar to how it worked with this jump example. So next, I come to run again. So really what I'm going to do here is just come down this existing path and increment all these values. So now you see that I have 2 for each of these values. And since all these words are the same, I'm just going to go through and update all these values, and we can see the final state of our trie. Okay, so now we have our final trie. This represents all of the words in our words array mapped to their letters and how many times each occurs. So you might be asking, how do we actually use this to answer this problem? Well, you might be thinking, okay, so let's maybe start at this first string and we can remove it, right? So effectively what we're doing is we're going to go down this tree path and we could say, all right, let's cross this out, let's cross this out, what's this out, right? So we basically remove it essentially, decrement those values, but then now what we have to do is we have to actually traverse this entire tree in order to actually find what the longest common prefix is. And you can imagine this would be slow, right? Because we essentially have to go through the trie, remove this string essentially, then we have to do another search to actually find the longest prefix, and then at the end, add this string back in so that we can go to the next word and process that one. So we don't want to do this. This is going to be too slow. But there is kind of an insight that you could take away from this, which will help you solve this much more efficiently. So one thing that we can realize is that we're actually only ever going to have an answer of 2 prefix, right? Our answer will either be one of 2 prefixes. So what we're going to do is we're going to find the longest prefix that meets our criteria, and then also the second longest. So longest makes sense, right? We're just going to go through and see what the longest in our try is. So here we see it's jump. So let's record jump here. And then we want to find the second longest after we remove jump. So let's remove this. And now jump appears one time. So now we can go through again and find the longest prefix, but you'll see that we can't use jump again because jump now only appears one time, and we have to have it appear at least 2 times. So our second prefix actually is going to be run in this case. So let's think about how we actually use these and why we know we can only use 2 prefixes. So there are really 2 cases here. If the word that we're looking at is part of the longest prefix, or rather the longest prefix is the beginning of this word, then we know that we're basically removing this longest word from consideration, right? So if we're removing the longest word, we know that the second is the one that we should use, because essentially we're removing this longest from our array, and because of that, we want to use this second one. The other case is where the word we're looking at is not the longest. And if we're removing one that is not the longest, we should just use the longest, right? Because we know that the longest will be unaffected. If anything, some other prefix that was shorter will be decremented. So in the case where the word we're looking at is not the longest, then we should just use the longest. So really there are 2 cases. Either the word that we're looking at is the longest, and in this case, what we want to do is use second. Otherwise, we use the longest one. So I want to show you why we can use exactly just these 2. So one thing which might be confusing is that the longest can actually be the same as the second longest. And let's see this case. So say jump actually appeared 3 times and our k is 2. So if we remove the longest, right, this becomes 2. So we know that our longest is jump, and then we remove that. So we want to find the second longest. Well, in this case, jump is actually still the second longest one, right? Just because we removed this doesn't mean that we can't have it again, right? So in this case, jump is actually both our first and second longest. So really what we're doing is just 2 searches through this tree. We're going to find the longest one, we're going to then remove it, and then what we're going to do is do another search and find the second longest prefix. And these could be the same, right? In this case, we see that they're actually the same exact answer. It really just depends on the exact problem that we're given and how exactly it's set up. So let's hop over to the code and see exactly how this works. So we're going to start with a pretty basic try setup. So we're going to have our try node class, and this is going to have its children that it references and also keep track of the number of occurrences that this node has occurred in the try. Then our try is going to start with its root as an empty try node. We're going to have one function to insert a word. So basically what we're going to do here is we're going to just iterate through all the characters. If there is not already a node in this child, a child in this node, we're going to add that in and then proceed to the word. Similarly for remove word, we're just going to go through our try, find each node for each character, and decrement by 1. So really just very basic try functionality. If you're not familiar with tries, I would recommend finding some videos out there on how they work, but this is very kind of boilerplate stuff. Then finding the longest prefix here. So basically what we're going to do is a breadth first search to just go through our try and find the longest prefix. So basically we're going to add just that root into our queue, and then while the queue is not empty, we are going to pop off whatever's in there. If the number of times this node occurs is less than k, then we know that this can't be part of our prefix, so we continue past. If this is longer than the maximum prefix we've found so far, then what we can do is just update our value. And then here, what we're going to do is for all of our children of this node, we add them into our queue so we can search those as well. This is really going to be the way that we actually find the prefixes and search through our try. So here comes the actual logic of the problem. So what we're going to do is we're going to start our try and insert all the words in there. So first what we do is we're going to find the longest prefix. Then we're going to remove it and find the second longest prefix. So what we're doing here is we're going to find the longest one, and we're going to say, let's think about the case where we remove this. We have to think about what the second longest one would be after removing the longest. So that's what we're doing here. We're removing it and we're finding the second. Then we start our answer array here, and this is where we actually generate the answer. So what we're going to do is we're going to go through all the words, and we're going to say, if the current word starts with the longest prefix, this means that we're removing that longest prefix from our try, so we should use the second longest prefix. Otherwise, if it doesn't, this means that we're removing something which is not the longest one. So the longest one will still remain the longest one in this case, and we should use that instead. Then at the end, we're just going to return our answer. So let's submit and make sure that it works. And it does work. So hopefully this is helpful and it made sense. If you liked the video, please like and subscribe, and thank you for watching.